Okay, so we're going to finish up Chapter 13 with a little bit more information about stock markets and the kinds of returns. So if you remember before, we looked at historical returns on the stock market, and you saw an extreme amount of volatility from one year to the next, depending upon what happens, things like housing markets crashing and the Great Depression and other such things. But one thing I pointed out was that the returns, if you looked at the average returns based just on stock value, it wasn't 11%, which is a number I quoted. So I found this additional tool which allows you to find out, in this case, what is the return on the Standard & Poor's 500, which is a conglomeration of the 500 largest companies that are public companies. And there are funds where they basically buy stock on every company on the Standard & Poor's 500. How often do they move people on and off? Yeah, I mean there is people moving on and off the Standard & Poor's 500. I don't know when they update it. Oh, really? Okay, yeah. Yeah. So what you can do is you can put in the beginning year and ending year and look at the average return, including reinvesting the dividends. So that's the other way of making money. I think I might have used this example. If I didn't, I didn't use it in this class. So when I worked for General Electric, I worked for them for 2 years after I got my master's degree, and when I left, usually have to work for a company for 5 years to become vested in their pension plan. So I wasn't vested, but I did get 2 shares of GE stock. So they sent me them in the mail, and I have not done anything with them except left them in there. And there's a few things that can happen. One is the stock price increases. Sometimes they take stock certificates and they split the stock. So if the stock's worth $100 a share, what they'll do is they'll make it $50 a share but give you an extra share. So you have the same value of the investment. They do that just because they don't want the share price to get so big that it just seems out of reach of buying it. So they would like, normally share prices are probably less than $100 a share. And also they reinvested the dividends. So you get dividends just like you get a part of the profits. And instead of giving you that money, they buy more shares of the stock. And that's the whole idea of dividend reinvestment. So I got 2 shares of stock, which I think I remember in 1982 when I left there, they were worth $200. I got two shares of stock, each worth $100. And I've left it in there, just let it accumulate, and now the shares are worth $5,000. So that was at a factor of 50-ish, something like that, 40, maybe 40 times, 50 times. Yeah, if it was 200 and it's 5,000, it was 20. Actually, it's a factor of 25. So if I had bought if I had the money and I had the knowledge, and if I bought 10,000 shares, $10,000 worth of shares back when I left, I would have $250,000 now. So that's a pretty big amount. If you go per year, I think I actually calculated it. I mean, it's reasonable, but it's not one of the better stocks. It's a kind of an average stock. So let's just look at some time periods here. This is the default is 10 years. So if you bought shares 10 years ago and you push the calculate button, what it does is it tells you what the total increase, so it's increased 69%. So if you had $10,000, the value of the stock would be now worth, if it was 10,000, it would be $16,900. Okay, that's how much you would have. And what they do is they give you an annualized rate of return. So this is to compare with the number that we used in that spreadsheet to look at whether we could afford retirement or not. So let me pull that up too, just so I can find that. So let's retirement calculator. Okay, so I'm going to pull that up to the top. We looked at this. Let me share that. So we're looking at the significance of this number right here, the return during accumulation. We used a 6% number. That's conservative. And just to show you the difference in the final amount, where does it tell you that? Gives you the, oh, here's the value of the savings. So at 6%, giving the defaults that they have, which I think was 10%, but no matching, just look at the relative differences, because it'll all be relative. The more, if you get twice as much money in, you'll have twice as much money when you finish. So at 6%, you have about $1 million after investing it for 40 years, each year putting in 10% of your salary. If you increase that to 11%, you have $3.5 million. So it's not, well, let's say you go from 6 to 12. So I'm doubling the rate of return. So at 6%, I get $1 million. If I double the rate of return, I've got 4.5 times the result. So this number has a huge impact on how much money you can accumulate through the years. So here there's 5.4%. That's if you don't reinvest the dividends. But if you have a mutual fund and you're not retired and you don't need the income, you're trying to accumulate savings, you can see the annualized return on investment is 7.6% when you reinvest the dividends. So that's almost 2 percentage points higher, which is pretty significant. Now, let's say I went back, when I started working full-time after getting all my degrees, it was 1986. So if I go from 1986 to the current time, and I push the calculate button, you can see that the rate of return based on the value of the stock is 7.8%. If you reinvest the dividends, it's up to 10.2%. So I'm getting close to that 11% that I kind of threw out there as being something that's realistic if you invest a lot in the stock market. Now you can't pick years where it was a bad decision. You know, if you bought in 2007, which was just before the stock market went down, and you invested it for a couple of years, like 2013, you actually only get around 1%. So, you know, stocks during that period of time were not that great. You know, another period of time, if I go back to 1926, and I invested until 1934 maybe, then I've lost 10%. You know, so there are periods of time when it goes down, but over the long run, if you take large periods of time, say for my example, my parents, my dad started working probably around full-time after World War II, 1947, and he retired in 1990, I think. Was it 1990? Anyway, we'll put 1990. No, it was actually it would have been 1990. It seems during that period of time, the stock market reinvesting the dividends got almost 12%. So that's a huge, go back to the calculator, putting 12% in there, you can generate a lot of money. Now, he didn't have millions of dollars or anything like that, so um, so the point is that historically, rates of returns of over 10% are not unrealistic. So now I'm going to give you my words of wisdom. Hey, did you? Yeah. So can't find it. What were you looking for? I forgot you told. Oh, the laptop. Oh. Yeah, I didn't see anything around. I probably would have normally run into it. Okay. Yep. Okay. Okay. So I'm going to give you my. So what we learned in chapter 13 was we learned about how the value of savings, whether it's savings or stocks or anything like that, given an annual rate of return, we can calculate how much we accumulate over the years. We were given formulas basically for a given initial amount and what would be the final amount. The reality of most people is you put in a little bit each month automatically in your savings, and that adds up. There's no easy formula. It's nowadays it's probably easier just to find a tool online that you can use. So you saw my retirement calculator there. You could use something like that to help guide you in deciding whether you're on the right path or not. We talked about car loans and how paying off the car loan, your payment consists of interest and the principal, and the payment is always going to be more than the interest, so that reduces your balance, and after a certain number of years your balance goes to zero, and that's a reasonably simple calculation using Excel. You also have talked about the average daily balance for credit cards. The bottom line there is you don't want to have a balance if you can help it. Okay, and then we talked about different strategies for retirement. We talked about 401ks and all that kind of stuff. So I'm just going to give you a little summary of my advice here, and it's not personal opinion. This is just pretty much a very conservative discussion. If I didn't do everything correctly during my career, I played it too safe, yeah. And if I had known more when I was younger, I probably would not have played it as safe, and I would have more money. I'm still okay anyway, so I'm not going to be greedy. But if I had less, if my jobs hadn't paid as much, and I hadn't been as thrifty, then I might have needed that to have been more. I would have been more reticent about not being more. What was the word you used? Risky, no, yeah, or a little bit more bolder in my investment choices. But okay, so first thing, college. So the things you want to minimize your debt coming out of college. That's not a surprise, right? So how do you minimize debt? Well, you go to a state school. That would be one thing that would be good. The tuition for state schools. You got to move to New York. Did you hear that? That New York is offering free tuition. So that's tuition. That doesn't mean room and board. So theoretically, if you live there and you could live at home, then you would have free tuition. And it's supposedly for middle-class families. So if your family makes more than $100,000, then you don't get benefit of that. But for normal people, that's a big deal. So in San Francisco, schools, yeah, there was some requirement that you work in the state for a number of years after. What's that? Yeah, and the New York thing was you had to live for however many years you went to college in New York. You had to stay and work in New York. Is it they also require? So you do state school, you go to community college, which you're already doing. Of course, you look for scholarships and I mean, you use loans as if you have to, but you want to minimize using loans because those loans for school are actually a little bit more restrictive and yeah. So I think probably they thought, well, we're going to put these restrictions on loans for colleges because they're more likely to get a job that they can actually afford to pay, and we don't want to give them excuses not to pay their loans. That's my fault. Whether that's true or they just thought they could get away with it. Yeah. Okay. So the other thing is you should look for a major where you can actually get a job. If you're not independently wealthy, I'll say which is employable. I mean, I chose when I was in college, I chose to be an engineer, which was good because I like math and science. Not everybody can be an engineer, but I also chose it because I knew that the job prospects for engineering were good. So yeah, pretty much most of the time. There have been a few times they haven't been great, but yeah, most of the time they're good. Okay, so that's my words of wisdom for college. You probably heard those before, but the second thing is, okay, so you get a job, and if most every company these days offers a 401k plan, so I'd say join the 401k plan. Contribute at least the amount the company matches, which a lot of times these days is 6%. So if you save 6%, the company will match 6%. You're saving 12% a year. There used to be this kind of rule of thumb: if you save 10% of your salary and put it into reasonable investments, that you should be okay when you retire. You just have to start early, and you have to not be too conservative on your investments. If you do either one of those, I didn't start till I was 28 because that was when I got my. I mean, I had jobs before then, but I didn't have anything that had a pension plan or a 401k plan. I went to school for a long time, so not because I failed, just because I went for a long time. But nowadays, I'm not even sure if they had 401k plans. I don't think that was implemented until after I'd been working for a while. But so once you do that, you'll typically be given a reasonably limited number of options. So it's not like you have 450 choices. It's not like you go to the mall. It's not like a man going to the mall and there's so many choices you bail out and to go home with nothing. You will be given some choices, and the ones that you really, if you don't want to think too hard about it, there's two things that you might look at. One is some kind of an index fund, and we just looked at this S&P 500, which is, there are index funds based on the S&P 500 because it doesn't take any investment research to pick the 500 companies because it's a public available list. You can have an index fund and they don't take much money out to manage the fund. So most of the increase goes into your pocket, not to a broker's pocket. So there's index funds, and then there also are called target date funds. And what those do is you put in the year that you choose the year that you're going to retire, and it picks a series of different funds that are well diversified. And as you get closer to retirement, it decreases the exposure to stocks and increases the exposure to bonds to minimize your risk. So those are two that are usually something like this is available. And the key thing with these is diversification. Diversification, which just means that you don't just buy one stock. You don't listen to Uncle Fred who says, hey, I got a stock tip for you. It's the greatest stock ever. And there may be those cases that works out. But a lot of times it's because Uncle whatever his name needs some money, and he's trying to steer you in the wrong direction, or he's trying to appear smarter than he is. So I wouldn't. Tanner. And Uncle Fred never points you. Yeah, that's right. He also voted for Trump. So. Yeah, I know. Yeah, right. Okay. If you believe, yeah. So buy that stock. If you believe that, buy that stock for Uncle Fred. It'll be just about as productive. Okay. Yeah, yeah, yeah. There's that one commercial for some investment thing, and it's saying, "Oh, but my dad, bought this stock, and it's got sentimental value, blah blah blah." And the guy says, "You gotta diversify. You've got to spread out your risk." Because I was saying this yesterday was, the question also you've got to not react to the stock market that much, because if the stock market's going down, I mean, if you were brilliant and you knew exactly when the stock market was going down, that's great. But most people aren't brilliant. They think it's going to come back when it doesn't. So, like in 2008, when it first went down 10%, oh yeah, it's coming back, and then it kept going down. And by the time you really realize it's still not coming, it's not coming up anytime soon. It's too late. So you just have to leave it in there and hope for the best. And the two scenarios are: it's going to come back up and everything's going to be fine, or it's going to keep going down and the whole economy collapses. And your money's going to be worthless anyway, and people are going to come out with guns and rob you. So you hope that doesn't happen, but it's not going to, the options are, you might have a little more money than the guy, but it's not going to buy anything. Anyway, so that's the main thing. Start saving money early. Don't be too conservative. I've never figured it out, but how much money did I leave on the table because I was too conservative? And I would say probably, how much do you say? $20. Probably a couple $100,000. Okay. So that's a lot of money. What's that? What's that? $20? Yeah, so it's, luckily my mother left some money to me, so that that helps out. Anyway, but not everybody gets that lucky either. You don't have, you can't always count on your inheritance. There was a friend of my wife's who she was talking to her recently about just the last few days. They went to high school together. They both have mothers who are ill, and so they talk about those kind of things, and they're about to not mentally ill, just physically ill. And so this other person, they're the same point in, Tanner, you're going to have to leave if you can't behave. Okay. Okay, I'll call your dad. Anyway, now that I know he's the police, now I know he's the sheriff in Blythe County. So that it's not that they have been not frugal. It's just that they have had the unfortunate fact of not having jobs that provided 401k plans or retirement plans. And she made the comment that right now, and they put most of their money into fixing up their house and their land. And so she made the comment that if either one of them died at this point, that they would not have enough money for a funeral. Okay, so that's, how much is a funeral? $10,000 if you if you don't get cremated. And so they're looking at doing a reverse mortgage because all they have, all the assets they have is a house. They don't have any money saved up. And Martha's thinking, you know, we're in pretty good shape. And she's just thinking, you know, how would that be if you got to that point and that's where you are? I mean, they're too close to retirement. They're never going to be able to catch up. So that just means you got to work, keep working. They will get some Social Security, but you know, it won't be sufficient really. And so it's not a fun situation if you don't plan ahead. Okay. Here's another piece of information just to share my personal experience. You don't always have to buy the newest car. Okay. I was listing my cars yesterday, so you don't have to write this down. This is my history of car buying. You'll see a trend here shortly. Honda. It's an Accord, an Accord, an Accord, an Accord. Okay, 1995. Oh, I forgot one here. 1989. You want me to do that? Okay. 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 Finally went to a Civic. Okay. So here's the used versus new. Okay. Okay, so you don't always have to have the newest car. You can buy cars that are used. And so here's the story, the car history. Here's my Carfax. My dad gave me the 67 Galaxy 500. It was kind of funny. Yes. I was just joking about Carfax. These are my Carfax, the facts about my car. No, just these are my cars. This is the car history. So I got my Ford Galaxy. I started driving it when I was a senior in high school because that was when I got my license because I was young, and it was only that was 1974. That was seven years old. Even at 7 years old, that Ford Galaxy seemed like it was 50 years old. It just seemed like a really old car. My wife was like, "This is the biggest bomb there ever was." And now a 7-year-old car doesn't seem that old to me. Anyway, that's one comment. So we drove that till we graduated from college. And we said, we're going to buy a new car. We've got a job. We're going to buy a new car. It was so great buying a new car, that new car smell, you know, just that experience of having a new car was wonderful. And then we bought it. So we traded in our Galaxy, got $500 trade-in on our Galaxy 500, which actually is pretty good back then. It was a convertible. It's probably a classic now. My wife still says it's a bomb, but it was a bomb. So we bought the Honda Accord new in '86, and then we traded in our 1980 Honda Accord, and we got a new 1989 Honda Accord. Those had the little flip-up windows. That was flip-up headlights. Yes, sir. I probably do. My wife doesn't. she has no nostalgic feelings about good feelings about that car. Yeah, probably got a reasonable price. Yeah. You think so? Okay. So anyway, the funny thing, the 1980 Accord, we had it 2 years in upstate New York, and it ended up rusting out so quickly. anyway, and then we got to this point. The reason we bought the 1995 Accord because we gave the 1989 Accord to our oldest daughter, so she'd have a car to drive. Then my wife wrecked this car, so she bought the 2000 Accord, and we gave the 1993 Accord. We bought the 1993 Accord for our younger daughter. So we ended up letting our kids have the older cars, and then we got the newer cars. But we never bought a new car between 1989 and 2010. That was a long time, but we saved a lot of money in the process. And so, again, that's just a little tidbit of advice. I don't have any regrets for buying used cars. Now that we're getting old, and I don't want to be stopped at the side of the road, once we might start thinking about buying a new car again, once the mileage is high enough that we're concerned about it. But anyway, I thought you might find that interesting. Okay, so that's it for my advice. Marry somebody who's thrifty. Don't buy it. Don't marry a spendthrift. Either way. Okay, we're actually moving back to Chapter 7 now. So this is our last. This is the what do you call it? The bell lap. We're going to be finishing up here soon. We only got 3 weeks left. Oh, by the way, let's talk about the exam. I'll tell you when the exam is. I think it's Tuesday. It's like one of the last days of the week, the last days of the exam week. So let me find it and then I'll share it. And if you have any questions about any other classes, I probably can show you you can find it out. So the way you read this is you look at when your class starts. So our class starts at 9:15 Tuesday, Thursday. I don't know if that's an option. Let's see. I think I looked at the wrong one the other day. Oh, there we go. Yep. So at 9:15 Tuesday, Thursday, it's from 8:15 to 10:15 on Tuesday morning, May 9th. Now I do have another exam which you can come to if for some reason you can't make the other one. My other class is here, so that's Monday from 12:45 to 2:45. So that would be another option. I can't accommodate a huge amount of people, but if there's some people that so those are the two options. And I might even give you, if there's some reason you can't get up at 8:15 in the morning besides, I don't believe anybody is in this room at this time, so I might be able to give you a third. Well, what I can do actually is I can tell you when my other exams are at 8:15, so that's 3 of my 4 exams turn out to be at 8:15. But anyway, the scheduled exam time is at 8:15 on Tuesday, May 9th. If it's a little bit late, sure. Yeah. I'll double check to see if there's anything after. I'll find out if there's any class in here that might be using the 10:30 to 12:30 time frame. It would be some administration of justice class. And I don't think I have a class in here until 10:30 and nobody's ever here, so I think we'll be okay. If you come in a little late, we can extend it because I'll just probably be grading tests in here anyway, so but I'll double check that. Now the next test which is our last test before the exam, will be on April 25th. So it's the Tuesday of the last week. So let me write that down. So April 25th, it's going to be in chapter 13 and 7. It all depends upon how far we get this week and next week. So what we'll do is whatever I cover probably by next Tuesday, that'll be on the final test, and anything that we cover Thursday or the last Thursday will be part of the final exam. It won't be the entire final exam, it will be part of the final exam. So I will give you at least, a week between the last material that we cover for the last test and the last test. Okay, so this is the first year that I've done algebra last instead of first, and we may not be able to get all the way through chapter 8, but that's okay. The other stuff was more important. And a lot of this is going to be review for some of you. So the question is, how do I get you to pay attention or make any effort at this? One thing is because it's going to be on the next test. That's always a motivation. And secondly, I think some people start out having difficulty with algebra, and it kind of sets the tone for their entire math career. And if you start too early to do algebra, the brain may not be ready to handle those concepts. So it's kind of like if you've had problems in the past, is just to say, well, I'm older now, let me start from the beginning, and maybe I'm not as bad as I thought I was. Okay, so try to improve your skills. Where is this useful? I mean, the reality is it's probably useful if you have kids and you can help them with their algebra homework. And secondly is that if you teach, you end up being an education major, you might have to teach skills that would feed into algebra. Most likely if you're, middle school or an elementary school teacher, you're not going to be, to teach algebra, you're going to be math major. So you're not going to be actually teaching these concepts, but you'll be teaching the concepts that lead up into this. So the way we're going to do this is these little green boxes that are in your book, we're going to read them, and where appropriate, I'll work out an example and explain some of the techniques to solve the problem. So chapter 7 is only linear equations of one variable, which you might even go back to 7th grade for that. But based on my experience, you have about half the class that knows what they're doing, and the other class never knew what they were doing, and they still don't learn it. So I know there's at least half of you guys that need this help. You need to be able to do this. And whether I don't do a good enough job or you just don't pay attention, I don't know which one it is, but I'm going to try. I try my best here to explain how to go through the mechanics of solving these equations. Because the techniques are not just related to algebra. When I get people in calculus or when I taught pre-calculus, a lot of times the biggest problem was they had poor algebra skills. And if you can't do the algebra, then you can't do the calculus. So it's so when you're solving linear equations in one variable, it's pretty much just basically solving for the variable x, because it's not x versus y. It's not like a point-slope form of the linear equation or a slope-intercept form of the linear equation. We're not plotting anything here. We're just solving for x. And even this, if you're doing physics, a lot of times you're solving for a variable. You're solving for something that you need to know, and it's a function of other variables which end up being numbers. So even in physics, these skills are important. You have to know how to do the algebra. So a linear equation, which I find interesting because I always read this and I think of an equation as like y is a function of x. Y equals some 3x plus 2. But I guess it's an equation. Linear, I think of something that results in a line, and it results in a line, but it's just a vertical line if you plotted it. So the linear part to me, but you don't really care about that. That's the linear part I always have a hard time with. So what you basically have is you have a term that involves a coefficient a, the variable x, which is what you're trying to solve for. You've got other constants, numbers, and the purpose is what value of x makes this equality hold. There's only one value. When you have a linear equation, there's only one solution. It's unique. In this case, they don't let a equal 0 because then you wouldn't have an equation. You wouldn't have any x term in there. You'd have 0 times x, which is 0. So there are two basic techniques that you use to solve these two things you have to do. One is the addition property of equality. So there's no variable in here, but it's talking about real numbers. So a, b, and c can represent any number, any real number, negative, positive, rational, irrational. And it says that if you have an initial equality where a is the same value as b, and you add the same quantity to both sides of the equality, that the equality remains valid. So what they're saying is that these two equations are equivalent, which means that if this is true, then that's true. If this is not true, then that's not true. So the same number it says may be added, I guess. The same number is added to both sides of an equation without changing the solution set. So if we have a linear equation like this and I add the same number to both sides, I still have the same solution. The value of x that makes this work is going to be the same as if I add another number, the same number to both sides. In that case, you might think you're making it more complicated, but if we're adding the correct number, we're actually simplifying it. So we use this property to simplify the equation to ultimately get to x equals something or y equals something. So from a number standpoint, it seems kind of trivial, but if you have an initial equality, because of the nature of numbers, this would be the original. In this case, a would equal 3 and b would equal 3. Obviously, the equality is true. And if you had c, you would say 3 plus 2 is equal to 3 plus 2. And we know that, and you can see just by the numbers, that it's true. If you have an equality 3 equals 3 and you add 2 to both sides, you get an equality. When you deal with a variable like x plus 1 is equal to 4, what we're saying there is if you add the same number to both sides and the equation becomes x plus 4 is equal to 7, the solution for this equation is the same as the solution for this equation. You can see if I put x equals 3, 3 plus 1 is 4. If I put 3 here, I'll get 3 plus 4 is 7. So the equality still holds. That's the whole idea. And typically what we're doing is we're not just picking some random number to just change the equation. We're trying to take an original equation and add some number to both sides that simplifies it, leads to the simplified result. Now you can also think of it from a physical standpoint. You can think about a seesaw. And if you had some quantity, like you have a box here that doesn't weigh anything, and inside the box is this unknown thing, and then you have another box over here, and inside's this unknown thing, and you take those two boxes and you put them on the scale with the same distance from the fulcrum, and the thing balances, then you'd know the things inside the boxes that you can't see are equal to each other, because that's just the physics of the situation. So this would be, this might be A and this might be B, and then you have some third quantity C, say this is C, and if I take that C and I make an exact copy of it, and I put this over here and I put that over there, if they originally are balanced, if I add the same amount, the same quantity to both sides, then the balance stays the same. Makes sense. So that's the addition property of equality. And the second one is the multiplication property of equality. So it says that if you have an initial equality and you multiply both sides by the same number, where C, this number C is not equal to 0, then the resulting equation is also an equality. So you can, again, physically from a little teeter-totter standpoint, you can kind of think of, again, if I create this little box with something in it, and I oops, didn't mean to do that. So if we group those together, try to group that together. Okay, so it is, and we just make some clones of it. If I take the same thing and I put it on either side like that, then it's going to be balanced because it's the same thing. A and B. I could put A and B, but I'm going to just use C. Now if I make, let's say, 5 copies of this thing, and I say, okay, now I'm going to stick 3 of them over here, and I'm going to stick 3 of them over there, and I made 1 extra I didn't need to do. You know, I know that's going to be balanced. So in this case, this multiplier is not C because I've already used C, but you know, C would be equal to 3. If I have an equality of 2 things, and I increase everything by a factor of 3 or just some common factor, or divide everything by some common factor, then the equality remains the same. That makes sense from a balance standpoint. I've got 3 of them over here, I've got 3 of them over there, so they balance out. So that's the multiplication property of equality. So we use those 2 properties and this following procedure, which again is in your book, and you can write this down later at some point. I don't want you to feverishly try to write all these steps, but the 5 steps, and sometimes we don't need to do every step, but we have to at least look at them and do them in this order. The first step is to remove any fractions that you have in your original equation. Now theoretically, you wouldn't need to remove the fractions, but it makes the problem a whole lot easier to solve if you do. If you have any decimals, you want to remove those. You want to end with the equation that only involves whole numbers. The second one is to simplify each side. So the first thing you do is if there are any terms that are multiplied by a quantity in a parenthesis, you get rid of the parentheses by using the distributive property. And then once you've gotten rid of parentheses, you combine the like terms on each side of the equation. You don't do anything between the 2 sides, you just do it on each side. Then you use the addition property of equality to isolate the variables x on one side and all the other stuff on the other side, which is just the constants, the numbers. And then you divide by the coefficient in front of the variable term to get a variable coefficient of 1, so that that's basically solving for the answer. And then ultimately you can always check your answer by substituting your solution back into your original equation. Now I'm going to do that some, but I'm not going to do it on the real hard ones. I'd rather spend the time making sure I do it right. And then there's also solving for a specified variable. This is when you have more than one variable in your equation, and all you're doing is solving for one variable. We'll talk about that later. We're going to talk about the first one, right? And what I'm going to do is I'm just going to take this example. We'll start off with an easy one, and then we'll get more complicated as we go along. So the first thing says clear fractions. Well, there are no fractions. Ultimately, what we're trying to do here is solve for x. So clear fractions, we've done that because we don't have to. It's already done. Use the distributive property to clear parentheses. So we don't have any parentheses, so we can skip that step. Combine like terms as needed. So you can see, let me put this on one screen. So what we're going to do is we're going to combine the like terms. So these are like terms. And these are like terms. And these are like terms. This one, there's just one of them. So we're going to combine them. And the way you combine them is you just add the coefficients. So 12x plus 15x is basically 12 plus 15 times x. So this becomes 27x. 5 minus 3 is 2. This one is only one term, so we just leave that the way it is. And then the last two terms we combine. 7 minus 1 is 6. So that's step 2, combining like terms. The next thing we do is we use the additive property of equality to isolate the variable term, which is this one, and this one on the right-hand side. So the way you do that is you take the additive inverse of the term that you're trying to move, basically get over here. So we're going to add 3, which is the additive inverse of negative 3. And you add it to both sides. So this is the part where we're adding the same thing to both sides. And you do that both for the variable terms, and you also do it for the number terms. So to make this, to isolate these terms together, we need to get this over to the other side. So one way is to subtract or take the additive inverse of whatever the term is. It's better to use, in some ways it's better to use additive inverse rather than subtract, because then you're not having to worry about taking the negative and negative. You're talking about changing the sign. So that's why I'm using the word additive inverse. And I usually put an equal sign between the two because they are equal to each other. That's the whole concept of they're equal to each other because they're the same thing. And then you do the math. So you're going to take 27x plus 3x, which is 30x. This goes to 0. This goes to 0. And this becomes 4. So that's what it means to isolate the variable term. This is the variable term. Because this is 0, so once you have 0 of something, you can just get rid of it, likewise here. And then finally, you're going to divide by the coefficient in front of the variable term. And what that does is you get 30 divided by 30, which is 1. The right-hand side you can simplify if possible. And then the last step is just to drop the 1. Only reason I do, you don't have to do that step, but in the actual description of the process it says to divide by the term, which gives you a coefficient of 1. So the coefficient is there, it's just 1, and once you have it there, you can just get rid of it. Okay, so that's, everybody should be okay with that, I would think. Okay, so let's make it a little more complicated. So what I'm going to do is I'm going to take this page. Actually, I think I already, let me take this. Clone. Put that there. Okay. So the next thing we have is, what if you have parentheses? So we're, again, adding complexity to the whole thing. So when you have parentheses, it says, use the distributive property to clear parentheses. So the key thing people make mistakes about when they do this part is, especially in the case we don't have it, but if this were negative and there's a negative inside the parentheses. So you just got to be careful to take into account the signs. Most people can multiply 4 times 2 and 4 times 3. Just be super careful about the signs when you multiply those together. Remember that this sign applies to both multiplications. And this most people don't have a problem getting it right here. I'll show you where people have a problem in a minute. Okay, so you multiply 4 times each one of these terms separately. Likewise, you take 3 and you multiply each one of those terms separately. So 3 times x is 3x, 3 times 7 is 21. And so once we've cleared the parentheses, we just continue on like we did last time. We combine these two terms, add the coefficients together. There's only one number term here. Likewise, on the other side, there's only one variable term. And then you combine the two number terms. So now I have simplified each side separately. So you should end up with 1 or 2 terms on each side. Then you use the additive property, addition property of equality. So I always like my variables to be on the left-hand side. So I need to get this number and eliminate that. So the only way you can eliminate it is by adding the additive inverse. And you do that to both sides. Same with, I want to eliminate this term from the equation, so I have to add the additive inverse. So the additive inverse of negative 12 is positive 12. And then I do the addition. So 20 minus 3 is 17, so I get 17x. This goes to 0, this goes to 0, and 12 plus 3 is 15. And then you divide by the coefficient in front of the variable term to get a 1 coefficient. In this case, you can't simplify it because there's no common factor between the two. Now I'm going to show you another way, which in this case you might say it's about the same. I don't really see an advantage, but when you get into more complicated stuff, it actually turns out to be more useful. At least that's been my experience. So rather than doing this step in this way, what you can think about is anytime you move a number from one side of the equation to the other, you change the sign. So the value stays, the size stays the same, but the sign changes. So what I could do is I could say, well, I want to get all the variable terms on the left-hand side. So if I take this variable term and I move it to the other side, by moving it, I change the sign of it. So this 3x on the right-hand side becomes negative 3x. Likewise, so I move this to the left-hand side, so it's not there anymore. And this one I'm going to leave on the right-hand side, but I want to move this to the other side. So when I move negative 12 to the other side, I change the sign. And then I can combine like terms. So 20 minus 3 is 17x. 20x minus 3x. And 3 plus 12 is 15. And then I can divide both sides by the coefficient, and I get the same answer. So what's the advantage of doing it this way versus doing it that way? Is you don't have this extra line in there. And when you deal with the equations that are only variables instead of numbers and one variable, but multiple variables, it's easier not to have this extra thing underneath here. It just confuses you to some extent. Now you're probably used to doing it that way, and it's fine to do it that way. I'm just telling you an alternative approach. You get the same answer, right? Well, it doesn't save you any time. You don't have to write this line, but then you have to combine the like terms in this step. Okay, so here's another one. So why don't you guys go ahead and at least multiply it out and combine the like terms and see what you get. Oh, I was going to tell you about, before you do that one, let's go back and tell you where people make mistakes. So let's say I have this equation, but instead of, I have -3 there instead of +3. So I'm just going to show you this. So you got to be real careful. This -3 has to be applied to both of these terms. So you would have -3x minus 21. A lot of times people they'll see the -3 and they'll multiply it by x and they'll get that right, but then they forget about the negative sign and they multiply 3 times 7 and they add 21. So that would be one example. Another case would be, say, -2 times x minus 1. So you've got -2 times x, which is -2x, which again most people get, but then they forget about the fact that you have -2 here times -1. So a negative times a negative's a positive, so that's going to be +2x. So just be real careful anytime you see a negative sign, either inside or outside, that you are appropriately multiplying the correct signs together. Okay, so go ahead and do that one. If you want to solve the whole thing, you don't have to wait to do that, but I'm gonna give you about a 2-minute lead time, and then I'm going to do the calculation. You can check to see whether you got it right or not. So here's one of those examples. -2 times 4 is -8, so don't forget the negative sign. So I got that. Anybody have any questions about anything I did? As just a matter of ease, even though, here I've got 7 minus 8, which is -1. I always like the variables one first. You don't have to do that, but it just makes it easier. So I've got a question for you guys. It's not anything to do with math, but so let's say you have a terminal illness. Something's terminal. And, they're saying has anybody experienced that? You have a grandparent or something and they're really ill, and the question is, how long do you think you have, right? Have I got a week? I've got 2 days. It's interesting. I don't think doctors really know exactly. You can't give them a number. How long is somebody going to hang on for whatever reason? You got a bad heart, you've got cancer, something like that. I mean, probably the last day you might know because your body's shutting down. But the fact is, so how many people think that if they were in that situation, it's the old question of physician-assisted suicide. So how many people think that's a good idea? How many people like that idea? How many don't like that idea? how many people are ambivalent about that idea? I guess you didn't raise your hand. Nobody wants to do it. So the reason I'm mentioning that my mother-in-law's at that point, and she's gotten to the point where there's nothing they can do. She's got a bad heart, and my brother-in-law's he texted my wife, or maybe she talked to him, and she said she woke up yesterday and she says first thing she says to the nurse was, "Why am I still alive?" But the problem is you can't. Yeah. I'm not going to do it. You don't have to give any resources. I'm just saying it's an interesting, as you get older, you deal with those things more, and that's not the first time this has happened, but that's the first time somebody's actually said that question. And the problem is you can't predict. I mean, just because they say something's terminal, you can never predict how long it's going to take, and how the body is going to keep going on. The body is meant to go on. It'll fight, even though you know that it's hopeless. Your body, because it's meant for survival, wants to keep going on. And so anyway, what's that? Yeah, I know. I don't know where I sit on the whole thing, but I'm not a one way or the other. Anyway, that was my little morbid thought for the day. But anyway, those are things people need to talk about. Okay, so the next thing we do is we want to get all the variable terms on the left-hand side. So we're going to do the additive inverse of the term that's on the other side. And likewise with the constant, we want this over the other side, so we take the additive inverse of that number, and then we add them together. 12 plus 2 is 14. This goes to 0. This goes to 0. Negative 1 minus 5 is negative 6. And then we divide by the coefficient in front of the variable term. You get x is negative 6 over 14, which then can be simplified into negative 3/7. And that's your answer. Now we could plug that back into the original equation. That's too hard. Too much time to do that. Okay. The next two are adding the first part of the problem, which is getting rid of fractions. So to get rid of fractions, you multiply by some number, use the multiplication property earlier than you normally do. So we're going to use it earlier to remove the fractions, and we're going to use it later to solve for the variable. So the easiest way is just to multiply the two denominators together and multiply every term by that denominator. In this case, that's the only solution. If there was a number smaller than the product of these two that is a common term, the least common multiple, then you could use that as your common denominator. But in this case, they don't have any common terms, so the least common multiple is 12 anyway, which is the product of those two numbers. So what we're going to do, instead of dealing with fractions, we're going to get rid of fractions immediately. And then we're going to just deal with whole numbers. So if we take this entire expression and multiply everything by 12, the equality will remain the same. So you'll have 8x over 3 times 12 minus 2x over 4 times 12 is equal to negative 13 times 12. And typically, you've chosen this because this times that is the result, so you can group these numbers together and simplify those, and they'll simplify to a whole number. So what you end up with is 8x times 4. 12 divided by 3 is 4. And you'll have 2x times 3 is equal to negative 156. Now you can multiply it out, so you get 32x, 8 times 4, minus 2 times 6, which is 2 times 3, which is 6, equals negative 156. And then you combine like terms, so you get 26x, 32 minus 6 is 26, equals negative 156. And then you divide both sides by 26. And you get x is equal to negative 6. So 156 divided by 26 is 6. And I know that because I've worked the problem before, but you would just use your calculator. But the key thing to remember here is that once I multiplied by this common number and simplified, I'm just down to a simple equation that involves whole numbers. I don't have to deal with whole numbers. Not that you don't want to be able to handle fractions, but it's better to just be able to do it. So we'll finish this up next time, but the last, well, I'm going to assign your homework at least this time. So here's your homework. When you have decimals, you can multiply by a common factor to remove the decimal part, which is kind of like what we just did with fractions, so it's not that big a deal. So those will be due next Tuesday.